Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In this video, I am going to discuss the concept of head-on collision. Consider two bodies M1 and M2 moving with speeds u1 and u2 as shown. Because u1 is greater than u2, certainly the distance between M1 and M2 decreases. Eventually, they hit each other. During this process of collision, they exchange their momentum and energy, and finally they get separated with velocities v1 and v2. With v2 being greater than v1, so the distance of separation goes on increasing. So this is head-on collision because when m1 hits m2, the force applied by m1 on m2 is towards right, and the force applied by m2 on m1 is towards left. The collisive forces are acting along this horizontal line. The line along which the collisive forces act is known as line of impact or line of collision or line of impulse. There are three names to that particular line. And if you observe in this case, the velocities of m1 and m2 are directed along the line of impact. Because velocities are directed along the line of impact, this collision is known as head-on collision or one-dimensional collision. For example, if there are two bodies, say m1 is moving in this direction, there's another body m2 which moves in some other direction, so they hit each other during their path. In this case, the collisive force will act along this line. The pink line you see is the line of impact, and the velocities are making some angle with the line of impact, so this kind of collision is known as oblique collision. In this video, I'll limit my discussion only to head-on collision or one-dimensional collision. In this case, there is no net external force if you consider m1 plus m2 as a single system. If you take m1 alone as a system, definitely there is force applied by m2 on m1. If you take m2 alone as a system, there is definitely force applied by m1 on m2. But on m1 plus m2 system, there is no external force acting in the horizontal direction. Of course, in the vertical direction, there is weight, and if they are on the ground, there is normal force. But the collision is happening along the horizontal, it is one-dimensional collision. So net external force in the horizontal direction is 0. The collisive force becomes internal force because my system is m1 plus m2. I can apply conservation of linear momentum on m1 plus m2 system. So the first equation is by conservation of linear momentum on m1 plus m2 system. Initial momentum of the system is m1 u1 plus m2 u2. Because the momentum of m1 and the momentum of m2 are directed along horizontal, you don't have to complicate this equation by expressing momentum in vector form. We can simply take rightward as positive, leftward as negative. So initial momentum is m1 u1 plus m2 u2, that is equal to final linear momentum of the system, which is m1 v1 plus m2 v2. m2 v2, this is the first equation. The second equation we get by Newton's law of restitution. When I say it is a law, it is based on several observations. That's how the nature is functioning. It is observed that for a given two set of bodies, for different values of u1 and u2, when the collision is performed between m1 and m2, they move apart with different values of v1 and v2. And there is always a relation among these four things, u1, u2, v1, v2. That is given by Newton's law of restitution, which says that the rate at which m1 and m2 are getting separated by the rate at which m1 and m2 are getting closer before collision, that ratio remains constant. The velocity of separation by the velocity of approach remains constant, which is known as coefficient of restitution. So second equation is by Newton's law of restitution. I'm using the shortcut NLR. The meaning of the word restitution is restoration. So Newton's law of restoration or restitution, it is velocity of separation by velocity of approach before collision remains constant, which is E. This E is named as coefficient of restitution. The velocity of separation can be expressed as v2 minus v1. Velocity of 2 with respect to 1. That relative velocity gives the rate at which the distance is increasing after collision. Similarly, velocity of approach before collision is u2 minus u1. This is velocity of m2 as seen from m1. That is u2 minus u1. But this quantity is negative because u2 is less than u1. u2 minus u1 is negative, obviously, because this rate, the rate at which the distance between m1 and m2 is changing, is decreasing function. So this is negative. We only need the magnitude. We only need that magnitude of velocity of approach. So that is minus of u2 minus u1. That is equal to E. So the second equation is v2 minus v1. That is E times u1 minus u2. This value E depends on the type of materials that m1 and m2 are made of, the elastic properties of m1 and m2. So for a given set of two bodies, there is a fixed value of coefficient of restitution, which is always a number less than 1. The value of E is less than 1. So solving these two equations, we can find v1 and v2 is m1 u1 plus m2 u2, that is equal to m1 v1 plus m2 v2, and we have the second equation as v2 minus v1 is E times a constant times u1 minus u2. So in this equation, I can eliminate v2 by expressing v2 in terms of v1. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 into v2. I'll write v2 as v1 plus eu1 minus eu2. So we got a linear equation in terms of v1. We can easily find v1. So let us solve this. I'll take u1 common. Then I have m1 minus em2, because m2 eu1 on RHS comes to LHS, plus I have m2 u2 common now because I have m2 u2 here in LHS and m2 u2. So multiplied by 1 plus E by or is equal to m1 plus m2 into v1. So v1, let me highlight the result. v1, the velocity of the first body after collision, is m1 minus em2 into u1 plus 1 plus E into m2 u2 divided by m1 plus m2. This is v1. Similarly, from the first equation, I can write m1 u1 plus m2 u2 is equal to m1. I'll eliminate v1 by expressing v1 in terms of v2. So v1 is nothing but, from this equation, v1 is equal to v2 minus eu1 plus eu2 plus I have m2 v2. Solving this, I have m1 u1 common and m1 u1, so into 1 plus E on this side plus m2, I can take u2 common, so m2 minus em1 into u2, that is equal to m1 plus m2 into v2 on RHS, as you can see. So finally I am highlighting the result of v2, that is equal to m2 minus em1 into u2. You observe there is a symmetry in these two equations, plus 1 plus E into m1 u1 by m1 plus m2. So these are the values of v1 and v2 after collision. You don't have to remember these results. You should only know the concept that for any problem in collision, there are two equations. If you have any questions or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and answer your questions. This is Vikram Dachepally signing off. Namaste.